Hi, my name is John H. Lee.
And I'm Glafcos. Havariyoun.
This video is on frequency filtering in physiological measurements.
We will start off by saying first of all what frequency filtering is. Well, it is the removal of unwanted frequency components and the enhancement of wanted ones in a signal. This can be done with either analog or digital filters, or even both.
As you can see in the animation, through the use of a variable resistor or any other appropriate component, frequency filtering can be varied. Analog filters are used to filter the incoming continuous signal before it is amplified and then digitized by the analog to digital converter. Now, filtering the signal before full amplification is essential for biopotential measurements to improve the signal-to-noise ratio. Passive analog filters can handle large signal with little distortion.
But on the other hand, digital filters can handle a wide range of signal levels without adding much noise. This is achieved using Fourier transforms. They extract the frequency spectrum of the signal, allowing the spectrum to be manipulated before being converted to the modified spectrum and back into a time series signal. This allows digital filters to achieve more complex and selective designs which would be impractical to make in analog form.
Here you can see an everyday example of why frequency filtering is important.
Hi guys, my name is Glafcos and today I'm going to use the hospital. Now the reason why frequency filtering is vital in these kind of measurements is that
As you have just experienced from the previous video, two different types of ambient noises were recorded along with Glafcos' voice. Similarly, during the actual measurements of muscle and nerve activity, a low amplitude neurophysiological signal is recorded in the presence of ambient noise. So, the filters act as to remove the selected frequencies to achieve accurate measurements of muscle and nerve activity.
While taking these measurements, different noise sources are encountered.
First of all electronic equipments generate electrical noise. This has frequency components that range from 0 to several thousand hertz, something which can be to a point resolved with the noise of high quality components.
Another source of noise is the ambient noise, which originates from sources of electromagnetic radiation, such as radio transmission, electric power wires, and fluorescence lamps. In fact, any electromagnetic device generates and may contribute to this noise. But the dominant concern for noise arises from the 50 to 60 Hz range of radiation from power sources, something which can be observed in these signals where frequency filtering of the mains was cancelled between those red bars.
The third type of noise is that the motion of artifacts. As you can see in the animation, there are two main sources of motion artifact, and both having an effect on the signal. One is from the movement of the electrode on the skin, and the other from the movement of the cable connecting the electrode to the amplifier. The electrical signals of both noise sources have most of their energy in the frequency range of 0 to 20 Hz.
Further contribution to noise in the signal is done by inherent instability of the firing rate in neurons. The amplitude of the signal is quasi-random in nature. The frequency components between 0 and 20 Hz are particularly unstable because they are affected by the quasi-random nature of the firing rate of the motor units, which in most conditions fire in this frequency range. Thank you for watching our video.
Thank you for watching our video.